Hello friends, welcome back to my YouTube channel Learner Again. Friends, today we learn about bridge rectifier. Let's now friends. An important rectifier circuit arrangement is the bridge rectifier H or double way rectifier shown in figure. In this circuit, the four PN junction diodes D1, D2, D3 and D4 are arranged in the form of four resistance of Wheatstone bridge network. So why it is known as bridge rectifier. The two opposite ends A and C of the network are connected to the ends S1 and S2 of the secondary of transformer, while the ends of B and D are connected to the load resistance R. This is the figure, friends. You can see now. This is the AC input and this is the resistors. This is the figure, friends. And we know working. Working under the action of an AC voltage applied to the family of the transformer. The voltage across the secondary is given by EI is equal to E naught sin omega t, which varies with omega t as shown in figure B. You can see figure, friends. In the half cycle in which the potential of the transformer has a polarity such the A is positive and C is negative, diodes D1 and D3 are forward biased and conduction takes place Y diode D1, load resistant R and diode D3. Consequently, a current I follows in the direction AB RDC S2 S1 A as shown in figure A. On the other half cycle, when the terminal C is positive with respect to A diodes D2 and D4 are forward biased, whereas diodes D1 and D3 are reverse biased. Therefore, conduction takes place while the diodes D2 and D4 and a current IZ follows in the direction ABRD S1 S2 C. Same process is repeated in the subsequent half cycles of an AC input. However, the current through the load R follows in the same direction in both the halves of the applied AC voltage. Thus, the current is unidirectional and the wave shape of the current in the load is similar to that of full wave rectifier. Since the two diodes conduct simultaneously in series, hence the current pulses are represented by I1 is equal to E naught 2R plus R sin omega t is equal to I naught sin omega t when 0 greater than omega t pi. It is equal to 0 and I1 is equal to 0. It is equal to E naught by 2R plus R sin omega t, I naught sin omega t, where R is the dynamic forward resistance of each diode and I naught the maximum current given by I naught is equal to E naught 2R plus R. This is the equation 1. The peak inverse voltage in case of bridge rectifier is the voltage across each diode and is equal to E naught, the maximum voltage across the secondary of the transformer. Rest of the parameters, example average DC current is equal to 2 I naught by pi. RMS value of current C is equal to I naught by under root 2 and the ripple factor is equal to 0.48 are the same as in case of center tap full wave rectifier. The efficiency of bridge rectifier is given by n is equal to 81.2 by 2r 1 plus 2r by r percent. This is the equation 2. Advantages. First, as the transformer secondary winding is fully utilized, center tap of the secondary is not required. It reduces the transformer cost in a bridge rectifier. The peak inverse voltage across each diodes in a bridge is only half as that of a center tap full wave rectifier for the same DC output. And then third, since the Current in both the primary and secondary of the transformer follows 4A. For the entire cycle, a smaller transformer can be used. Disadvantage: two extra diodes are required in this circuit. Thank you friends, we meet in next video. There friends, this equation 81.22R 1 plus 2R by R. There is R friends. Okay. Thank you friends, we meet in next video.